Okay, so starting off with geometry. Section 1 of Chapter 1. We're looking at patterns and inductive reasoning. Okay. All right, so first off, here are two different patterns, and I want you to identify what the next two numbers would be in this. Okay. All right, so once we have these two, okay, we're going to come back to them in a second, and we're going to talk about them a little bit more. But basically, what you did here is inductive reasoning. You have a sequence, or you have a pattern, and you've continued the pattern with it. So that is inductive reasoning. So inductive reasoning is a type of reasoning that reaches a conclusion based on a pattern of specific examples or past events. So if you see something's happening, and then you go, oh, this is what will happen in the future, that is inductive reasoning. Okay, so predicting what it's going to be based on past results. The next thing on this is a conjecture. So conjecture is the conclusion that you reach with inductive reasoning. So it's why it is. So if I count by the numbers 2, 4, 6, 8, you would say the next number is 10, and I'd say why? You say because you're counting even numbers. Me counting even numbers is the conjecture. Okay, so that's the conjecture. Is the reason why you move from one number to the next. Okay, so let's go back to these previous ones. So the first one, the next two numbers of this one, 3, 6, 12, 24, are 48 and 96. Okay, so 48 and 96 are the next two numbers. And the reason is because I am multiplying every one by 2. So it's 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48, 48 times 2 is 96, or doubling. Okay, so that's how we are getting our next numbers. This is your conjecture. Why are you getting the numbers? How are you getting the next two numbers? Okay. The second one, Washington, Jefferson, Lincoln, Hamilton. Next two would be Jackson and Grant. And the reason it's Jackson and Grant is because you're going by the faces on U.S. currency. So Washington's on the 1, Jefferson's on the 2, Lincoln's 5, Hamilton's 10, and then on the 20 is Jackson, and Grant's on the 50. Okay, next one after that would be Franklin. And so the conjecture for that would be what is the next currency up, who's on that. Okay, so make a conjecture for the sum of the first 35 odd numbers. So when you're trying to make a conjecture for it and try to figure out what it is, what you're going to do is you want to start off small. So if we want the first 35 odd numbers, the sum of them, let's start off with the first odd number. First odd number is 1. The sum of the first odd numbers is 1. First two are 1 and 3. That sum is 4. Next one is 1, 3, 5. That means we're up to 9. Then we have 1, 3, 5, 7, which gets us up to 16. And then the next one would add 9 into it, which gets us up to 25. Now, the question is there anything special about these numbers? So 1, 4, 9, 16, 25. Is there anything special that we have with these? And so as we're counting these up, there is something special about them. Every single one of these are called a perfect square. And so a perfect square means you can take the square root of it and you get a number. 1, 2, 3, 4, 5. And so as you see here, however many odd numbers we have, that's the square root. So with this one, if we want to do it, we would take our 35 and we would square it. And that would be our answer for the sum of the first 35, which means our conjecture is the number of odd numbers squared will tell you the sum of all the odd numbers up to that point. So this is our conjecture. Okay, counterexample. So what a counterexample is it's something that disproves a conjecture. So if I state a conjecture and say this is true, if you can find something that doesn't agree with it, it is a counterexample. Okay, so the counterexample is anything that disproves a conjecture. Okay, sometimes these are very easy to find, sometimes these are a little more difficult. So let's see if we can find a counterexample for this. So Alan, if we can. Sometimes counterexamples do not exist. Alan makes a conjecture about slicing a pie. He says that if you use only straight cuts, so no curves, no zigzag cuts, the number of pieces will always be twice the number of cuts. And he gives the first two examples here. when you do one cut, you end up with 2 pieces. When you do 2 cuts, you end up with 4 pieces. So now let's move on to the next one. So if we have 3, how many, if we have 3 cuts, does that mean we have to get 6? And the answer to this is no. I can cut it 3 times and not get 6 pieces. So there's one with 4 pieces. Okay. There's another one with 1, 2, 3, 4, 5, 6, 7 pieces. So you see, I did 3 cuts 2 different ways, and I didn't get doubled. I got more and I got less based on the cuts. Okay. So counterexamples can be found many different ways. Okay, so counterexample for each of these. For the first one, so the sum of any 2 numbers, or if 2 numbers is greater than either number, if you do, let's say, -1 and -2, you add those 2 numbers together and you get -3. That number is not greater than either of them. Okay, so that would be an example of a counterexample. Second one, the product of 2 positive numbers is always greater than both numbers. An example of this could be 1/2 times 1/3. 1/2 times 1/3 is 1/6, which is actually smaller than both the other 2. So that would be an example. Those would be counterexamples for these statements. Again, if I'm just saying numbers and positive, I'm not saying that they have to be whole numbers. I'm just saying numbers. Okay, so you should be able to find counterexamples for a lot of different things going forward. Okay, so let's use inductive reasoning to find the missing number. So I've got 1, 2, 3, 4, 5, 6, 7, 9 times 9 gets us that. Same thing times 18 gets us that. Same thing times 27 gets us that. So the last one, if we multiply that by 36, what should we get? That's right, it should all be 4s. So it should be 9 4s. Okay, and then if we multiply the next one by 45, they should be all 5s. Next one by 54 should be all 6s, and etc., etc. That's us using inductive reasoning because we've identified a pattern. Okay, so find a counterexample. So the difference of 2 integers is less than either integer. Okay, so a counterexample of this could be 5 minus a -2. 5 minus a -2 ends up getting us a +7. That's greater than both those numbers. And so that would be an easy counterexample. So again, you just have to try to figure out any positive number minus a negative number will actually get you a larger number. And again, they're integers. Integers are nice whole numbers. Okay, so the table below shows the number of VHS videos or tapes over the past few months. So the top one is the month, the bottom one is the number sold, and we want to make a conjecture to see if we can predict the number of movies sold in July. Okay, so if you look at this pattern as it's decreasing, we go, okay, what do we think it's going to be in about July? You could find the average difference going down. So this one would be 2, and then 4, and then 3, and then 3. So it looks like it's dropping by about 3 every time. So that means in July, so next month it should be about 42, and then we have 39. So it should be about 39 in July, approximately. Again, you could graph it, draw a line, and see what you get. But again, it's an estimate. So as long as you're around 39, you're probably going to be fine with this, because again, it's a prediction. So now the next question is, how confident are you of using the same conjecture to predict the number of tapes sold in December? Okay, so would you be confident, or would you not be confident in making a prediction for the number of tapes sold in December? Now, this is kind of an opinion, but there is some ways you can think about it. Okay, yes, it might continue falling, but if it keeps falling, what's going to end up happening? You're going to end up with a zero. Now, the question that you might want to ask is, does it bottom out anywhere? Is there going to be a point where you're always going to be selling 10, no matter what, because of some reason? Is it going to bottom out? Is it going to slow up? Now, the other thing is you might want to think about what's the situation. It's December. What happens in November and December? You're getting close to the Christmas season, which means that you might end up selling more. So that means you might end up getting a little spike. It might go back up to that 50 and then it drops. Um, so looking at this, how confident would you be? I personally would say I'm not very confident because um, looking at something and predicting it 8 months in the future is very hard to do if you only have the previous 4 months, 5 months before that. It's very hard to predict what's going to happen. Now, if you had the previous history and you can see, oh, this is what the sequence is going, that's one thing. But based on what we have, we don't know what it's going to look like. And so I would not be very confident doing a prediction going into December. It's a little too far away from me. All right. All right, that's the end of this first section.